Welcome to this tutorial where we take a look at the walt.id community stack and its three main products: Issuer, Verifier and Wallet. We will see how we can create a digital ID wallet, then how we can receive credentials from an issuer in this wallet, and then how we can request and verify credentials from the wallet using the Verifier product. This will be a video walkthrough of the tutorial you can also find in our documentation, as you can see here on my screen. So with no further ado, let's get started. First of all, we need to think about the credential we want to issue. The community stack offers different types of credential and credential formats you can issue. In this tutorial, we will be focusing on a W3C credential with the type university. But you could also issue a university degree not in chart format as we will do, but in a ST-chart format, and thereby enabling selective disclosure, where a user can, when presenting a credential to a verifier, decide which type of properties in a credential they want to share if they are selectively disclosable, and thereby reducing the data that is shared with a verifier to the minimum. You can also issue ST-chart VC credentials, which is another format, or MDLs. Let's now continue with our W3C credential. Here we can see an example university degree, where we have contextual information, a credential unique identifier, the type, which will always be inheriting the verifiable credential type, and then our custom type, in this case, university degree. The issuer DID, so the unique identifier of the issuer, which is here a DID web. Then an issuance date, and most importantly, the credential subject. So information about the credential's recipient and the degree they earned. Here we have the ID of the receiver, which is also a DID, and then the degree data itself. To get started, we need to set up the issuer, the wallet, and the verifier of the community stack. For that, we can use the Docker Compose by cloning our walt.id identity repo and then bringing up the Docker Compose, which will expose these different endpoints. I already did that, and I have now the Swagger APIs up and running: the issuer, the verifier, and the wallet. We will first start off with creating our wallet. As we will be using the walt.id wallet API, we will create a so-called custodial wallet, which means that the keys of the wallet are managed by the operator of the software, so ourselves in that case. But there are also scenarios where you have non-custodial wallets. Here the keys are mostly stored then on the user's device, so only the user can access them. Now, back at the wallet API, we will create now our first wallet account. Here I will provide my information, set a password, and create. Now I have a wallet account, and by default, so we can now also log in to this wallet account. So let's do that first. Now that we are logged in, we will see that by default, we will get one wallet ID assigned, because potentially in the future, there could be multiple wallets per account. And so we will use this account/wallets endpoint to get a list of all the accounts. And here we can see, and I will be saving this now for later reference. Also, by default, and this can be configured, the wallet will create a set of keys in the DID, so a unique identifier based on the type JWK for the user. And so what we can do now to also verify this is by listing out here my keys. And here we already need this wallet ID, which we just got. And here we can see I got one key pair, which is an ED 25519 key. And when we list my DIDs, we can also see that I got one DID JWK in my account. So this is all good. We are all set up. We have our key, we have a DID, and we have a wallet account. Now we need a credential. And that's where we will now go to the issuer and issue ourselves the credential. And here in the issuer API, we will be using the chart issue endpoint. And in the body of the request, we will define the key information. So which key will be signing this credential, the credential configuration ID, which is required by the OID for VC standard, which is the protocol we will be using to exchange the credential from the issuer to the wallet in a standardized way. They were also ensuring interoperability with other solutions that build on the same standards. Now, when we quickly take a look here at this well-known OpenID configuration endpoint, which is a standard endpoint by OIDC, we will see here information about the issuer. And especially interesting for us is we see here a map of credential configurations supported. And here we also see our university that is supported. Because if, let's say, I would now be issuing, instead of the university degree, another type, I would also need to configure the issuer to support this. You can also find here more information in the documentation, because otherwise we can't issue that, as it will fail as soon as the wallet tries to understand what the issuer is allowed to issue. But let's now continue with our issuance request. Here we also have this onboard issuer endpoint, which you can use to create a key and a DID. So here we can see a key created and a DID create. Now this is really useful when you do local testing or proof of concepts, where key information doesn't need to be highly secure. Because at the end, what we do here is we expose the private key information in code directly, and it's not in a secure environment. And therefore, for our example, we will be using this. So we will provide this key with the private key information here directly in the request. For production use cases, we offer integrations with leading KMS solutions like HashiCorp Vault, AWS KMS, Oracle, and others. So you can then directly here connect with an external KMS solution, thereby ensuring that the signing of the credential will happen in the KMS's environment, and thereby ensuring that the keys never leave the secure environment. Now, what's especially now interesting for us is this credential data, because this will be where we now will provide the information about our credential. So quickly looking here, I will also now just copy out this whole example body from the tutorial. What we can see now here in the credential data, we will provide the credential we saw in the beginning of the tutorial, where we have the context, the ID. This ID will be actually then replaced later with a unique ID, which we will see when we here talk then about the mapping function. The type, the issuer, which will be also replaced by a mapping function. The issuance date will be also replaced by a mapping function. And the credential subject, where here also the ID will be replaced by a mapping function, as we don't know yet the ID also from the credential subject, so from my wallet at the end. And the degree. So what are now these mapping functions? These mapping functions help you to call so-called data functions, where you can also find a list in our documentation. When we quickly go here to our issuer, we have here a list of data functions, like for example, the UUID. And this data function is just a piece of code that will be executed in the backend, and it will return, in this case, a unique identifier. Now, the interesting part here is that when we now execute this function, this endpoint, an OID for VC offer URL will be created. This offer URL holds information like the type of the credential that will be issued and the issuer. But it doesn't yet include the actual signed credential, because this will be only created later. Because when the wallet gets this OIDC offer URL, which will be the response of this call, it will first contact the issuer to get the issuer metadata, like we saw before here with this endpoint. And then it will do a few exchanges to first do an authentication and also a proof of possession, where it will share the DID information, or in this case then my DID, from my wallet account. So the one we requested here, this will be shared also with the issuer. And then after these exchanges, only then will the wallet request from the issuer in the final step the actual credential, which the issuer will sign. And exactly in this last step, when the issuer then prepares the credential and sends it off to the wallet, these data functions will be executed. Now, the good thing is, with this, we get the ability to, for example, get here the subject ID. So this did, my did from my wallet into the credential, because we don't know it when we start the issuance flow in this scenario. And so here we can get the subject did, and this will be inserted. And then we also get other information, like here the issuer did, we can insert, create a unique identifier, also set an expiration time. And so we can use these mapping functions to insert different types of informations into this credential data we provide here. Then two last attributes we can provide here in the body is, first of all, the authentication method, which relates to the exchange mechanism used with the OID for VCI protocol. So in this case, we will be using the pre-authorized flow, where we say that the user is already authenticated and can receive the credential directly. And then there's also a standard version parameter, which defines the version of OID for VCI. Here in the headers, we can also provide a status callback URI, which will be called at the different stages of the issuance request, which can be really helpful if you want to keep external systems informed or do certain business logic, execute certain business logic during the issuance stages. Then also session TTL to define a custom time to live session lifetime, as it's by default to 5 minutes. Now let's execute this. So when we execute it, we will get back this OpenID for VC offer URL. And we could now also decode this quickly. And as we can see here, we get this credential offer URI. So we will, here the offer is provided by reference. So we need to call this endpoint to get the real offer, but it could also be provided directly here as value. Now, when we open this, we can see what the wallet will receive. It will receive the issuer information, so that it also then knows how to communicate with the issuer, like to get the information about the metadata. Then grants, so here the pre-authorized code, which will then be used by the wallet to authorize and get a code, so it can then later call the issuer to receive the actual credential. And then information about the offered credentials. So in our case, the university degree in this W3C chart format. So now taking this back at the wallet to receive the credential, we can use the use offer request endpoint. And here we will provide first the wallet ID and then the credential offer we created via the issuer. Now, when we execute this, we can see we have now received the credential. And here the document is the chart, so the credential as a chart. And so when we go now to chart.io, paste it in here, we can see that this is the credential we issued via the issuer, so which we specified here in this request. So we have the type, the university degree, here now the actual issuer did, the issuance date, be today, the did of the subject, so my did JWK, the degree, and the other information. Let's now go and request this credential from a verifier. So we will be using the /verify endpoint in the Verifier API, so this one right here, where we will now specify the credential we want to verify. So copying here quickly out the body, the verification request, and what we will specify here is the credentials we want to request. And in our case, it's the university degree in the chart VC JSON format. Now, this is a really basic request where we don't specify any specific verification policies, for example, and just let the Verifier API apply the default signature policy. But we could also extend this request to include other types of policies, like the expiration policy, or when we quickly go here to the docs, the not before policy, the schema policy, but also the revoked status list policy if this credential would have a status associated with it, or a holder binding policy. And there are many different types of policies we have. Also, dynamic policies, where you can write policies in the Rego language from the Open Policy agent, or also parameterized policies, like for example the webhook policy, where you can specify an endpoint, and during the verification flow, this endpoint will be called with the credential that was presented by the wallet. And so you can do then any type of verification and give the result back to the verifier, and there it will be processed to be treated either as valid or not valid. And so there are many different ways on how you then also can integrate your custom business logic. But let's now stay here with this basic example. In the headers, we can specify a success redirect URI or error redirect URI, where the user will be redirected, so the wallet user, after a success or an error. We can also provide a status callback URI, so similar to the issuer, where then an external system can be informed about the different stages during the verification request. Also an API key to authenticate this URL. You can also specify as a custom state ID, which will be inserted in this authorization request the verifier creates if we want to. Also different types of BP profiles, so standard profiles if we want to. We will just leave here the default one, and also the session TTL if we want to modify this to our needs. I will just leave here the default and execute this function, and what we will get back is this OID for VP authorization request URL, which can be now passed to the wallet. First of all, also decode this here, and what we will see, especially interesting for us, is a presentation definition URI. So the presentation definition is used to outline to the wallet which type of credentials it should present. Now, with the request we have defined here, what at the end happens in the background, that the verifier takes this request, the simplified format, and then turns it into a presentation definition. But you could also provide your own custom presentation definition if you wanted to, or also in the future a DCQL query. And so that's what the verifier then created. Basically a constraint on the VC type to be university degree. So now when we go to the wallet, we need to do a few different types of steps in order to process a presentation definition that is coming from a verifier. And the first step, when we quickly look here in the tutorial, so the first one we already did. We decoded this request and then extracted the presentation definition. So this one right here. And now we can use this presentation definition, which we extracted, to look for credentials in our wallet that match the specific presentation definition. And so we will take this here and in the wallet use here this match endpoint, and I will quickly provide my wallet ID here. And as we can see, it returned one credential that matches this presentation definition, so the one we issued earlier, which is this university degree. And what we will now do is save here this ID of the specific credential for the later steps. And when we quickly go back here, so we found our credential that we need to present. So normally when you would build a wallet, you would now present the user of the wallet with a screen that they can consent that you will be sharing, so as operator of the software, the credential with the verifier. Now, as we are here the operator, we can skip this step and just go on to share the credentials with the verifier. So first, we will need to call the resolve presentation request endpoint in the wallet, which is this right here. First, I will provide again here the wallet ID. Then we need to provide the authorization request from the beginning, from the verifier. Then we will copy this out here and can now move to the next step, which is use presentation request endpoint where we then now present it and share it with the verifier. So here we provide what we just got back from our previous call, presentation request. This DID we don't need because we just have one DID in our wallet. And so it will be chosen as the default one. This disclosure we also don't need as we don't have an SD short credential. And now the selected credentials here, we need our ID, which we extracted earlier with this match presentation definition endpoint. And of course our wallet ID. So now when we execute this, we see, okay, here's no redirect URI provided, as we could have specified right here. And now that the wallet has shared the credential via the OID for VP protocol, we can now go back to our verifier and check if what the wallet has shared is actually valid and passed our policies. And here in the authorization request, we have this state value, which we could also customize via this one header parameter. And so now when we take the state value and call this endpoint height here, so session ID, we will get back the result of this presentation session. And you can see here the VP token that was shared by the wallet. We also see that the verification result is true, so it was successful. And we also see here in the policy results map, in this results array, all the different policies that were applied. So first of all, the verifiable presentation, the signature was verified and was valid. And also we see here on the university degree, so the credential, here we also have the signature policy applied and it was successful. So in general, the verification passed. And so now if we had provided different types of policies, like the webhook policy or other static policies like not before policy, these would be also showing up in this policy results list right here. And with that, we reach the end of our walkthrough of the Issue Verifier and Wallet of our open source community stack. If you enjoyed our tools, please leave us a star on GitHub. We would really appreciate it. Hit the like button and subscribe if you enjoyed this video. With that, happy building and see you next time.